Hi everyone, welcome to Eduretics, where we make your high school life simple. I'm Aniket, and today we're beginning with our AP Calculus series. So if you're preparing for the AP Calculus AB or BC exam, this series is going to be a must-do for you. Okay. So in this video, we're going to do a total refresher, which is required before you start your full-fledged preparation of AP Calculus exam. So make sure you try out the questions which we do in this video, and you'll be all set to start preparing for your AP Calculus exams. Okay, let's go ahead. Okay, so let's start with this exercise. This is, I'm again repeating, it's a really important one for all of you who aspire to go for the AP Calculus AB or BC exam. This is a very good practice exercise before you begin your full-fledged preparation. Okay, it's like a diagnostic test, so everyone must attempt. A1, if f of x is equal to x cubed minus 2x minus 1, then f of negative 2. Just put in the values. This becomes negative 8, this becomes a 4, this becomes a negative 1, this is going to be negative 9 plus 4, negative 5. Option B. A2, the domain of f of x is equal to x minus 1 upon x squared plus 1. If you look at x squared plus 1, it's going to be always positive. It's an expression which is always positive. That means all reals. There's no restriction on the denominator of this function. A3, the domain of g of x is equal to root of x minus 2 over x squared minus x. So domain they're asking, definitely they're asking for what's not allowed, because in general all reals would be there, but we'll have to look at the denominator to see if at all it becomes a 0. So x times x minus 1 is the denominator. So x is equal to 0 and 1 are not allowed. That means option B. We forgot one more thing, the square root symbol. So under the square root symbol, only positive numbers are allowed. So x must be greater than or less than equal to 2. So that would be there. So not option A, but option B. Take care. If f of x is equal to x cubed minus 3x squared minus 2x plus 5 and g of x is equal to 2, then f of g of x. That means all x's would be replaced by 2. 2 cube is 8, minus 2 to the 4, 3, 12, minus 2 times 2 is 4, plus 5. 8, 5, 13, 13 minus 12 is 1, 1 minus 4 is negative 3. Option C is correct. You see, I've skipped A4, question number A4, because that was g of f of x. If you're asked g of f of x for these two, g does not have a dependency on x. That means inside, whether you put f of x or h of x, any other function, this is again going to be a 2. G of x of f of x is still going to be a 2. Okay. That's why I skipped that question, but I showed you right here. Okay. A6. If f of x is equal to x cubed plus ax squared plus bx minus 3, this expression, and if f of 1 is 4, f of negative 1 is negative 6, what is the value of 2a plus b? So we need to solve for a and b. F of 1 is 4. Put f of 1 as 4. So 1 plus a plus b minus 3 is equal to 4. 1 minus 3, negative 2. Negative 2 goes to the other side, positive 2, positive 6. So, and this is positive a. A plus b is equal to 6. First equation. Second, f of negative 1 is negative 6. Negative 1 plus a minus b minus 3 is equal to negative 6. A minus b is equal to negative 1, negative 3, negative 4. Negative 4 goes to the other side. Negative 6, positive 4, that is a negative 2. These are the two equations. Add them together. 2a is equal to 4. A is equal to 2. A is equal to 2. B is equal to 4. You can see on these equations. So 2a plus b, that's an 8. Okay. Which of the following equations has a graph that is symmetric with respect to the origin? Okay, symmetric with respect to the origin, that means it's an odd function. It's an odd function, that means if you do f of negative x, you will get negative f of x. Let's check which each of the function. Y is equal to x minus 1 upon x. If I do negative x here, negative x minus 1 upon negative x. If I take the negative common, the function will change. It will become x plus 1 over x. So that's not correct. This will not change since it's an even function. 2x raised to the power 4, even power. X cubed plus 2x. Let's do a negative x. So negative x cubed minus 2x. Take a negative, x cubed plus 2x. Yep, so this is negative fx. x cube plus 2, that's wrong. Why? Because negative fx is negative x cube minus 2. And if you do f of negative x, you will get negative x cube plus 2. So they're not the same. So option C is the correct one. Always put the negative x in, try and check if it's equal to negative fx. Okay, let's go ahead to the next question. Okay, question number 8, A8. Let g be a function defined for all reals. Which of the following conditions is not sufficient to guarantee that g has an inverse function? Okay, so for inverse, what's required? For inverse, it's required that the function is strictly 1 to 1. Okay, that's the only condition you need, that the function for which you're finding the inverse, that needs to be strictly 1 to 1 mapping. Okay, let's say we look at A, option A. So g of x is equal to ax plus b. Ax plus b, if we know this is the nature of the graph, we for sure know that it's going to have an inverse, because this is a straight line. Straight line will always have an inverse because it's a 1 to 1 mapping. G is strictly decreasing. Okay, let's say any function g is strictly decreasing. If it's strictly decreasing, that means again 1 to 1 mapping. No vertical line gets cut in 2 places. No horizontal line gets cut in 2 places by this graph, because it's strictly decreasing. So every succeeding value of the function compared to the preceding one will be a different value. Okay. Now option D is a very obvious one, that g is 1 to 1. Yeah, 1 to 1 mapping, then it will have an inverse. So g is symmetric to the origin. Again, symmetric to the origin is quite a good indication that the function would be having an inverse, but is it sufficient to guarantee that it will have the inverse? Let's check. If we say that there's a function symmetric to the origin, this function is symmetric to the origin. This is a cubic function, graph of a cubic function. It's symmetric to the origin. And yes, the inverse for the cubic function exists. But is it necessary that any function that is symmetric to the origin will have an inverse? The only condition for inverse is 1 to 1 mapping. Is there any function possible that's not a 1 to 1 mapping but symmetric to the origin? Let's check. It's very well possible, and here is how. Let's say this is a function. It's symmetric to the origin. Don't go on the shape. We can draw it symmetrical to the origin. But what's happening? If I draw a horizontal line, it's cutting the graph in multiple places. Similar for the vertical line, but horizontal we can directly see here. It's cutting in multiple places. So that means it's not 1 to 1 mapping even after being symmetric to the origin. So this kind of a function will not necessarily have an inverse. So option C is the correct one here. G is symmetrical to the origin. That's not enough condition to guarantee that g of x will have an inverse. Okay, next question. Let y is equal to f of x is equal to sine of arctan x. Then the range of f is. Arctan is another name for tan inverse. Okay, so arctan, this means tan inverse. Sine of, just a second, sine of tan inverse x. This is the function given to us. Now they're asking the range of f. So tan inverse x, so to check the range, we need to check the domain of this first. So the input going into sine is tan inverse x. That's going as the input. Okay. So what input? So tan inverse x. If x is something, what's the range of tan inverse x? The range of tan inverse x is going to be the domain for the sine of tan inverse x. So tan inverse x varies between, tan x varies between negative infinity to infinity in the range of minus pi by 2 to pi by 2. If we check for only the non-repeating interval, this will get inverted in case of tan inverse x. So tan inverse x will take in values as negative infinity to infinity and give out the output as minus pi by 2 to pi by 2. Okay, so this is the input which is going into this function, minus pi by 2 to pi by 2. So sine of negative pi by 2 is going to be negative sine of pi by 2 or negative 1. Sine of pi by 2 is going to be positive 1. And they're not going to be equal. because the infinities here are open spaces. Like the tan does not actually reach negative infinity or infinity, so it does not actually give out negative pi by 2 or pi by 2. It approaches those values, so it's the open interval. So option A is the correct one here. So see it again, this is a classic composite function question. The thing that's going inside, like the domain for this function is basically the range of the function inside. Okay, let's go for the next question. Let g of x is equal to mod of cos of x minus 1. The maximum value attained by g on the closed interval 0 to 2 pi is for x equal to. Okay, so maximum value attained by g. It's a mod, so it's going to be always positive. What could be the maximum value? The maximum value could be when, so cos of x can take the minimum value as minus 1, maximum as positive 1. Between these two, if I put positive 1, 1 minus 1 is 0. If I put negative 1, that's when this becomes maximum, because it will become mod of negative 2. Negative 1 minus 1. Mod of negative 2 is a 2. So basically we need the value where cos is equal to negative 1. So where is cos equal to the integral values? It's at n pi. So basically 0, pi, 2 pi, 3 pi. At the odd values of pi, or odd multiples of pi, cos gives out a negative value, and at the even multiples of pi, it gives out a positive value. So pi is the correct answer. Between 0 to 2 pi, pi is the input at which cos will give a negative 1, and hence the gx will attain its maximum value. Okay. Next, which of the following functions is not odd? Okay. Fx is equal to sine x. Sine x, if you check, it goes like this. Okay, so sine x is an odd function. Why? Because sine of negative x is minus sine x, and also we can see that it's symmetrical about the origin. There's symmetry about the origin. Whereas for cos x, there's symmetry about the y-axis. So that's even. Okay. Sine 2x will again follow the same thing, because whatever the input, as soon as we change the input to a negative, it will become a minus sine 2x. So this is also odd. A is also odd. Option C, x cube plus 1. If I put a negative x in place of x, I get a negative x cube plus 1. Whereas, what's the negative fx for this? It will be negative x cube minus 1. Basically, negative fx is negative of x cube plus 1, or negative x cube minus 1. For option D, we can see if I put negative x, it's going to be negative x over x squared plus 1. And the same thing for negative fx. You put a negative x over x squared plus 1. That's again going to give exactly this. So option C is the one that is not odd. Okay. If the solutions to the equation f of x is equal to 0 are x is equal to 1 and negative 2, then f of 2x is equal to 0 at x. So we are given the solutions to this equation. We need to find the solutions to this equation. Okay. This is a classic transformation question. X replaced by 2x. If you do 2x, we speed up the things. You directly see x replaced by 2x. That means whatever was happening at x is equal to 1 is now happening at x is equal to half. Because half times 2 is a 1. So whatever happening at x is equal to 1, at x is equal to 1 we had a solution. Now it will be at half. At x is equal to negative 2 we had a solution. Now it will be at negative 1. Half of that. Because we have doubled the speed of x. So half and negative 1, option A. Okay. Let's go to the next question. The values of x for which the graphs of y is equal to x plus 2 and y square is equal to 4x intersect are. Okay. So two functions are given. Y is equal to x plus 2, y square is equal to 4x. Okay. So I can place y as or I can say y squared. So I'll place this value of y here. X plus 2 squared is equal to 4x. X squared plus 4 plus 4x
is equal to 4x if we expand the squared formula. So now 4x and 4x cancelled, x squared plus 4 is equal to 0. What's the first thing that comes to your mind? This is not possible. Okay, x squared plus 4 is going to be an always positive expression. It can never be equal to 0. So no intersection. Option D is correct. The function whose graph is a reflection in the y-axis of the graph of 1 minus 3 raised by x is. Let's do some quick transformations. Okay. Let me change the color. First I'm drawing 3 raised by x. This is 3 raised by x. Then we have negative 3 raised by x. That means reflection in the x-axis, negative 3 raised by x. Then there's a positive 1 added to it. Lift 1 unit up. Okay. So x is equal to 0. When x is equal to 0, this was equal to 1, a negative 1 here. So now it crosses. We added a positive 1, so at x equal to 0, it's going to cross the origin. Graph is raised 1 unit up. This is the new graph. So basically our final graph looks like this. Okay. And this here is 1. It's raised by 1 unit. So now we need to check whose graph is a reflection in the y-axis of the graph of this. So reflection in the y-axis of the graph, we again need to take a reflection in the y-axis. So our final function is going to look like this. This is the thing. Okay. Now let's check. We'll check first option A. Option A is 1 minus 3x, 3 raised by x was our given function. This is 1 minus 3 raised by negative x. Okay. So it's pretty straightforward, yeah. Soon as you do negative x, like x tends to negative x, x transforms to negative x, we take a mirror image along the y-axis, about the y-axis. So option A is the correct answer. You don't need to check. But we can still check some quick transformations. 3 raised by x is this. 3 raised by negative x is going to be this, mirror in the y-axis. Minus of 3 raised by negative x is this. Plus 1 is going to be raised up. So our answer is correct. So basically, before you proceed with the AP calculus preparation, transformations and all should be at the tip, at your fingertips, basically. Yeah, the tip of your mind, tip of your hands. Okay. Option A is correct. Let f of x have an inverse function gx, then f of g of x is. Good question. The immediate solutions that come into mind are 1 and x. Either one of these two could be. So fx has an inverse of gx, f of g of x. So basically we take keeping the inverse inside and then doing the function. Let's take an example. Y is equal to sine x. Then there would be something called sine inverse x. That would be a function. Okay. If we do sine of sine inverse x, that's what they're asking. Sine of sine inverse x, we are just going to get x. Okay. We can take another example. Let's say x is pi by 3 or 60 degrees. X is pi by 3. So if x is pi by 3, I do sine inverse of pi by 3. I'll get some value. Sine of that will give us again pi by 3, the value from which that was obtained. Y is equal to x squared. Another example. So the inverse would be x is equal to y squared. Y is equal to basically root x. So y is equal to x squared. This is the function. If I put root x into this, root of x squared, it's going to give out x. So basically our answer is option B, because for each case it's going to be x only. Okay. Next question. The function fx is equal to 2x cubed plus x minus 5 has exactly one real 0. It is between. Okay, now they're saying that this function has exactly one real 0. It is between which two values? If it were between any two values, how do we check that? let's say these are the two values. If it has a 0 in between these two values, it would be something like this, increasing or decreasing. In any case, you see there's a sign changeover. This is the negative region, top is the positive region. That means there's going to be a sign change if I find out the f at these two values, the value of the function at these two values. So let's check with the options. If I do f of -1, option A, f of -1. So this is going to be -2, -1, -5, -8, and then a 0, 2, oh no, this is 0, this is 0, this is a -5. Okay. So no sign change here, as we see. There's no sign change for the first case. Next, 0. At 0 is going to be -5. At 1 is going to be 2 plus 1, 3 minus 5, -2. Again, no change. At 1, what did we find? -2. At 2, 2 times 4 times 2 times 2 is 4 times 2 is 8 times 2 is 16 plus 2 is 18 minus 5 is 13. This time there's a sign change, -2 and 13. This is our correct answer, option C. Because for option D, we'll get positive values for both 2 and 3. Option C is correct. Just look at the sign change, that is enough to tell you that there's a crossover. Next question. The period of fx is equal to sine of 2 pi by 3x is. I could apply the direct formula. That's time period is equal to 2 pi upon coefficient of x inside the sine input, 2 pi by 3. 3 is the answer. Why do we do this? Because if I just look at sine x, the period of this is 2 pi. The moment I multiply something with x, let's say I do kx, I'm speeding up the x-axis, the graph I'm speeding up by k, a multiple of k. I'm scaling x by a multiple of k. So it will take lesser time to repeat now. The graph will take lesser time to repeat, and that's what the definition of time period is, or period is, that the x value is taken for the graph to repeat itself completely. Okay, so that's going to be 3 this time. That's why we divide 2 pi by k. We scale down the period because the speed is up, so period would be lower. The range of y is equal to fx is equal to log of cos x or ln of cos x is, we need to find the range, like what outputs this would give, this function. For that, we need to see what input is being given to it. And for that input is basically the output of cos x. Let's draw a quick diagram. X goes into cos x. Cos x goes into log of x. And then the output. So x, all real x go inside. What's the output? Cos x gives -1 to 1. Now, log x will not accept -1 till 0. It'll start accepting values from 0, open. This is closed bracket, but 0 would be open because ln is not defined at x is equal to 0 inside. And then it'll take all the way up to 1 closed. Okay. So at 0 open, it's a -infinity. This is the ln graph for your reference. So it's a -infinity at x is equal to 0. At x is equal to 1, the log graph crosses over to the positive side of the y-axis. So it's going to be 0 will be taken as equal. -infinity will be open. So option A. Okay. That's the answer for this. It's again a composite function question. Let's go for the next ones. Okay. If log of 3 raised by b to the base b is equal to b by 2, then b is equal to. Okay. A good question on logs. So log of b, log of 3 raised by b to the base b. This will come out similar to like log of x raised by m to the base b something. So m comes out. So b will come out. B log of 3 to the base b is equal to b by 2. B and b cancelled. Now log of 3 to the base b is equal to 1 by 2. Now let's do the transformation. Let's remove the log. So basically 3 is equal to b raised to the power of half. Okay, that's the conversion. How? I'm doing it quickly. Log of x to the base a is equal to y. In this case, x is equal to a raised to power y. This is the general statement. Both are equivalent, because if you take the log to the base a on both sides, it's log of x to the base a is equal to log of a raised to power y to the base a. Y will come out. Log of a to the base a is 1. So you'll get this statement again. Hence, we do this conversion. Okay. 3 is equal to b raised to power half. That means root b is 3. B is 3 squared, 9. Let f inverse be the inverse function of f of x is equal to x cubed plus 2. Then f inverse x is. Oh, you simply need to find the inverse function from the given function. So what's the procedure? Y is equal to x cubed plus 2. Interchange x and y. X is equal to y cube plus 2. Now write y in terms of x. So y is equal to x minus 2 cube root. Option D. The set of x-intercepts of the graph of fx is equal to this is. What do we mean by the set of x-intercepts? What is the meaning of x-intercept? The points on the x-axis where, like the points where the graph cuts the x-axis, or where y is equal to 0. So basically they're asking us the zeros of this function, this polynomial. As you can see, it can be simplified directly. X squared taken in common from the first two terms, x minus 2. Minus 1 taken common, x minus 2. X squared minus 1 times x minus 2 put equal to 0. X is equal to plus minus 1 and a 2. Plus minus 1 and a 2. Option B. Okay. Next, the domain of f is restricted to the open interval negative pi by 2 to pi by 2. Then the range of fx is equal to e raised to the power of tan x is. Okay. This is the function e raised to the power tan x. The domain is limited to negative pi by 2 to pi by 2, open interval. Tan of negative pi by 2, that's negative infinity. Tan of positive pi by 2, that's positive infinity. So basically e raised to the power negative infinity to positive infinity. We're giving the complete domain to the function. So what does e raised to the power x graph look like? E raised to the power x graph. At x is equal to negative infinity, it starts from 0, goes all the way to positive infinity. That means set of positive reals. Okay. There are two options. Option B is set of positive reals. Option C is set of non-negative reals. They might look similar, but option B is correct. Why? Because the set of non-negative reals includes 0 as well. But this function is never actually equal to 0. Y is equal to 0 is basically a horizontal asymptote to the function. It's approaching 0, but it'll never actually be 0. Okay. Next question. Which of the following is a reflection of the graph of y is equal to fx in the x-axis? In the x-axis, that means the function is going just opposite. This goes to this. That means negative fx. Y is equal to negative fx. Okay. This 24th question could have been asked in a different fashion for multiple correct responses as well. If they give you an input graph and an output graph and then ask you what changes might have been done in that case. Yeah. Okay, let's look at the next question. Okay, tan of arc cos or cos inverse negative root 2 over 2 or negative 1 by root 2. Okay. Cos of negative theta is basically cos theta. Okay, because it's positive in the fourth quadrant as well. That's why. So cos of negative theta or negative angle is equal to cos theta. Why? From the graph also it's clear. You see,
0 to pi by 2, 0 to negative pi by 2. Both are positive. Okay. That means they're asking us tan of cos inverse 1 over root 2. Okay. Or cos of, okay, it won't change. We cannot apply that rule here. Cos of negative theta is equal to cos theta because it's cos inverse. It's not cos theta in the first place. So cos inverse negative 1 over root 2. When does negative 1 over root 2 occur? In the cos graph. Okay. So for finding the inverse, what graph do we take for cos? We take this much. Okay. So now, no, it's not exactly 1 to 1. It would be only this. Yeah. Only the right half. Okay. In this, negative 1 over root 2 occurs when this is pi by 2 occurs at plus 45 degree to pi by 2, or pi by 2 plus pi by 4. This is 3 pi by 4. So basically tan of 3 pi by 4 was the value. So tan of 3 pi by 4 is basically sine of 3 pi by 4 over cos of 3 pi by 4. Sine of 3 pi by 4 is going to be 1 over root 2 over, it's going to be positive for sine because sine stays positive all the way till pi. So 3 pi by 4 is less than that. So 1 over root 2 upon cos of 3 pi by 4 is negative 1 over root 2. So the answer is a negative 1. We did not exactly need this much time for this question. It's just that the initial thing took time where we saw cos of negative theta is equal to cos theta. That was not required in this question. Okay. If f inverse x is the inverse of f of x is equal to 2 e raised power negative x, then f inverse x is, we need to find the inverse. 2 e raised power negative x, this is y. Just a second. To find the inverse, we interchange x and y. Okay? They get interchanged. X is equal to 2 e raised power negative y. Now, how do we get an explicit function of y? For that, we'll have to use ln now. We'll take a natural log on both sides, or that is simply log to the base of e on both sides. So for that, we'll first write x over 2 is equal to e raised power negative y. This is just to simplify the calculation. Now we'll take natural log on both sides. Ln x over 2 is equal to ln e raised power negative y. Now the base is e here. So what happens? Negative y comes out. Ln e of to the base e, that's just 1, simply 1. Ln is equal to x over 2 on the left hand side. Now y is equal to negative ln x over 2. Negative ln x over 2, that means ln x over 2 raised power negative 1 or ln 2 over x. So option A is correct. Okay. Next question. Which of the following functions does not have an inverse function? Okay, let's check the options. Option A, y is equal to sine x for x between negative pi by 2 and pi by 2. So what's the condition for inverse function? Must be a 1 to 1 mapping. Between minus pi by 2 and pi by 2, sine of x is equal to, goes like this and this, minus pi by 2, pi by 2. The inverse does exist because it is 1 to 1 mapping. Okay. Y is equal to x cubed plus 2. I straight away do, so x cubed, cube function will again have an inverse. It will be a 1 to 1 mapping function. We can also check by the definition, like if I interchange y and x, we will get that kind of function. Option C, y is equal to x upon x squared plus 1. Let's see if this has an inverse or not. If I interchange the x and y, x is equal to y upon y squared plus 1. Okay. And then what kind of function is this going to be? The denominator x squared plus 1 is going to be always positive. So it totally depends on the numerator. Okay, does not have an inverse. Let's check option D as well. Y is equal to ln of x minus 2, log of x minus 2, where x is greater than 2. Quickly draw the graph of log of x. At this value, at 1, it becomes 0, and then at 2 it's going to be, okay, it's going to become 0 at 1, so that means it's going to become 0 at x is equal to 3. It'll become 0. Okay, the function at x is equal to 2 is going to be infinity. So from here, this is what they're asking. So yeah, it's a 1-to-1 mapping. This has an inverse, this has an inverse, this has an inverse. So option C naturally does not have an inverse. We don't need to check for that exactly. That's another good way to solve. Like if you are to avoid any complex methods being used, you can directly go for the options. Okay. Okay. Question 29. Suppose that f of x is equal to ln x for all positive x and g of x is equal to 9 minus x square for all real x. The domain of f of g of x is f of g of x, the domain. Okay. So it's going to be ln of 9 minus x squared. This is what they're taking in. In general, what's the domain for a log function? It's 0, infinity. X belonging 0, infinity. Now, for 9 minus x squared to be 0, as soon as x crosses 3, soon as x becomes greater than 3, this is going to get negative, which is not allowed. So x greater than 3, not allowed. X has to be less than 3. The moment it is less than 3, let's say it is 0. The moment it's 0, it's a 9 here. Okay, then it goes negative. This value keeps on increasing, the x square value. Negative 1, it'll give a 1. Negative 2, it'll give a 4. Negative 3, it'll give a 9 again, which will make this 0. That means it has to revolve. The values have to be between negative 3 and 3. So x should be less than mod of 3. That's how we'll say that. Or sorry, mod of x should be less than 3. Mod of x should be less than 3. One and the same thing. So mod of x less than 3. This is option C. Okay. And not less than equal to, but less than only. Because if it becomes equal to 3, we're gone. The input inside will become 0. Okay. Question number 30. Suppose that fx is equal to ln x for all positive x and gx is equal to 9 minus x squared for all real x. The range of f of g of x. Okay. Earlier they asked the domain, which is this, mod of x less than 3, this one. And then now they're asking for the range. So ln 9 minus x squared and we're told that mod of x is less than 3. That means x is between negative 3 and 3. It's going to repeat the behavior. The behavior from 0 to 3 will be seen in 0 to negative 3 as well. So the minimum, when does it occur? Occurs at x is equal to, okay, when x is equal to 0, when x is equal to 3, when x is equal to negative 3. At 3 and negative 3, it's going to negative infinity, basically, yeah. It's going to negative infinity. At x is equal to 0, it's ln 9. So it's basically less than or equal to log of 9, ln 9. Basically, ln 9 is one value. And then, so if I say 0, 3, negative 3. Here it's a negative infinity, here it's a negative infinity. Just at this point it's going to be ln 9. So the range is less than equal to ln 9. Option C again. Okay, let's go to the next questions. Question number 32. These are star marked questions. Why? Because these are revision questions given from the perspective of the AP Calculus BC exam. Till now the questions which we were doing were common to both AP Calculus AB and BC. Now these star marked questions are specific to AP Calculus BC. So those of you who are appearing only for AB, you can choose to skip or you can continue watching. Okay. Which equation includes the curve defined parametrically by x of t is equal to cos square t and y of t is equal to 2 sin t? Okay. We'll try to resolve them into an equation. X is equal to cos square t, cos square t, y is equal to 2 sin t. Okay. Now let's resolve it. The easiest way I can see here is to use the cos square x plus sin square x identity. So this is cos square t, this is a 2 sin t. Let's do 4x squared. So becomes 4 cos squared t. You will know very soon why we did 4x squared, because to make this as well. So now this y squared, as soon as we do, it becomes 4 sin squared t. Now we can sum them up. 4 cos square t plus 4 sin square t, that would be equal to 4, because cos square t plus sin square t is 1. So 4x squared plus y squared is equal to 4. This is the actual equation. 4x squared plus y squared equal to 4. Option C. Okay. Find the smallest possible value of theta in the interval 0 to 2 pi, closed interval, for which the rose r is equal to 2 cos 5 theta passes through the origin. The rose, so rose is kind of a graphical shape. R is equal to 2 cos 5 theta. This is a polar function, like a function written in the polar form. So r is equal to 2 cos 5 theta passes through the origin. When it's passing through the origin, that means the r would become 0. So r would become 0. That means 0 is equal to 2 cos 5 theta. Simply cos 5 theta is equal to 0. When does cos give a 0? At pi by 2, 3 pi by 2, like that. Smallest value, pi by 2. So 5 theta is equal to pi by 2. Theta is equal to pi by 10. That's the answer. Okay. Option C. For what value of theta in the interval 0 to pi closed do the polar curves r is equal to 3 and r is equal to 2 plus 2 cos theta intersect? Intersect, that means the value of r is 3. 3 is equal to 2 plus 2 cos theta. 2 cos theta is equal to 1, cos theta is equal to half. When is cos theta half? At theta is equal to 60 degrees. 60 degrees pi by 3. That's the value. Okay, option C. So these were the 34 questions. We're done with this. It's highly recommended that you practice all these questions. It's a good refresher. You might find problems with a few questions, but it's really good for setting you up for your full-fledged preparation of the AP Calculus exam. Okay, so keep following the series. We'll be coming out with new videos. The next video is going to be on limits. There would be 2 parts to that, and then we'll do more. Okay, all the best. Like, share and subscribe. Keep an eye on the content on this space. We'll keep releasing new videos for this. Okay, thank you.